This procedure covers the replacement of the MCXL spindle motor. Tools required are a T6 and a T10 Torx, a 2.5 millimeter Allen wrench, an Explorer, small slotted screwdriver, needle nose, an O-ring lubricant, and the MCXL calibration kit. First, we're going to go into the service software. So we'll click on the Start button, go over to Programs, highlight CEREC, and select Service. We'll go ahead and enter in the password, which is the month and the day reversed. Next, we're going to go into the light barrier stop position test. Prior to replacing the motor, we're going to remove the burrs. So here we're going to click on Adjustments, and then click on Stop Set 1. This will allow the motors to go into the lock position. From there we can remove the burrs prior to doing our replacement. After removing the burrs, let's back out, and now we're going to go into the stepping motor test single step. Since we're going to replace the left motor in this example, set the displacement value to 50 by pressing the down arrow. Then on the left motor, press the up button and continue to press the button to move the longitudinal shaft out. We want to move the motor just far enough so that you can get your finger behind the motor, because you're going to help push the front housing out later on. Now we'll remove the motor. The screws denoted by 1 hold the two motor housing halves together. The screws denoted by 2 are the screws that hold the motor to the milling shaft. We'll first start by using either a 2.5 millimeter wrench on earlier units or a T10 Torx for newer units. Remove both screws that hold the motor halves together. Using the same wrench, remove the 2 screws that hold the motor to the milling shaft. Be careful. At this point, once the screws are removed, the whole motor can rotate. We want to keep the motor in its position. Rotating the motor or pulling the motor off may cause damage to the wiring harness. Okay, holding the rear housing in position and using your finger to push against the back of the motor, use a small slotted screwdriver and pry the halves apart. Don't push the screwdriver in too far to damage the gasket. Once you have it separated, holding the rear housing in place, pull the front half out. There'll be a harness with a connector. At that point, disconnect the harness. And also note that there's a little bridge connector. The bridge connector may be on the motor or on the harness. Remove it at this time. Next, we're going to remove the rear housing. Press the harness back down inside and carefully remove the rear housing. Always inspect the harness afterwards to make sure there's no nicks or damage to the connector. Here we'll replace the shaft O-ring. Use an Explorer, remove the old O-ring off the shaft. From your motor kit, take a new O-ring. Using lubricant, grease the new O-ring before sliding it onto the shaft. Make sure the O-ring engages the groove properly all the way around on the shaft. Now we'll remove the motor from the front housing. Using a T6 Torx, remove the 3 mounting screws. Then pull the motor out of the housing. Note that in the housing there is a black O-ring. Remove the old O-ring from the housing. Now take a new O-ring from your kit. Using lubricant, grease the new O-ring and place it back into the housing. Make sure it engages the depression properly. Now take the new motor from the kit. Note that there is a red dot on the cable. That red dot must be against the motor housing. Bend the harness back over, making sure that the red dot is against the housing. The red dot should not be facing up. Now, using more lubricant, grease the O-ring on the front of the motor. The connector must engage the white bracket in the housing. Place the motor into the housing, engage the connector into the bracket, and seat the motor into the housing. Make sure that the motor is completely inserted. Then reinstall the 3 mounting screws with the T6 Torx. Make sure that the motor is completely seated. Look for any gaps. If the rear motor housing gasket was damaged as shown, or there is evidence of moisture in the housing, replace the gasket from one with the kit. Otherwise, leave the original gasket on the housing. Now we'll reinstall the rear motor housing on the shaft. Push the harness down inside the shaft as you slide the rear housing over it. Slide the housing back against the O-ring. Now we'll lube the back seal on the motor prior to installing onto the shaft. When the shaft harness connector is plugged back into the motor, the dot on each connector must be facing the same way. If your harness is long enough, you may be able to connect the harness to the motor before inserting the motor back into the rear housing as shown. However, if you're unable to do this, then you must install the motor and slide it into the housing and make the connection before putting the two halves together. This is shown in the next procedure. With the harness connector with the red dot facing up, slide the motor back into the housing. Engage the connector and use a screwdriver or a small probe to guide and push the connector in on both sides. Before closing the housing, you must make sure that the connector is fully seated. Failure to do so may result in motor errors. While keeping the rear housing stationary, push the front housing back against the rear housing. Next, put a small amount of Loctite on the 2 shaft screws and place into the motor. While holding the motor in place, Lightly snug the 2 shaft screws. Do not tighten completely at this time. Next, put the longer motor housing screws into place and tighten both motor housing screws. Then go back over and tighten the shaft screws completely. Redo all the screws one more time to make sure all of them are tightened securely. To finish the procedure, run in the motor with the load inlet test for approximately 10 minutes, calibrate the milling unit, and finish with a test mill.